You built a slick agent that works perfectly on your laptop, and the moment you try to ship it to production, everything falls apart. Cold starts, timeouts, orphaned processes, memory that vanishes between requests. The gap between it runs in my notebook and it survives real traffic is where most agent projects quietly die. Here's the uncomfortable truth. LangChain and CrewAI were both designed for orchestration, not deployment. They assume a long-lived process with state living in memory. Serverless platforms assume the opposite. Functions that spin up, do one thing, and die in seconds. So when people say, "I can't deploy my agents," what they usually mean is they're trying to force a stateful, multi-step reasoning loop into an environment that expects stateless, short bursts. That mismatch is the real enemy, not the framework. Let's start with LangChain, because it's the one most people reach for first. LangChain's strength is its modularity. You can swap models, retrievers, and tools like Lego bricks. But that flexibility comes with heavy imports. A cold start on a fresh Lambda can take 4 to 8 seconds just to load the dependency tree before your agent does any actual work. In serverless, that's billable latency and a terrible user experience. The fix is real, though. Strip your deployment down to only the LangChain submodules you use, lazy load the LLM client, and move your vector store to an external managed service instead of loading embeddings into the function itself. CrewAI takes a different philosophy. It's opinionated around multi-agent collaboration. You define roles, tasks, and a crew, and it coordinates them for you. That's fantastic for complex workflows, but it's also where serverless bites hardest. A CrewAI run often involves multiple agents talking back and forth across several LLM calls, and a single crew.kickoff can easily run past a serverless timeout of 30 or 60 seconds. If your platform kills the function mid-crew, you lose all the intermediate reasoning and pay for nothing. So how do you actually make either one work? The pattern that saves both is decoupling execution from the request. Instead of running the full agent inside the HTTP handler, you push the job onto a queue, SQS, a Redis stream, whatever you like, and let a separate worker or a durable execution engine like AWS Step Functions or Inngest process it. The API responds instantly with a job ID, and the client polls or listens for the result. This sidesteps timeouts entirely and turns a fragile, all-or-nothing run into something you can retry and resume. The other half of the problem is state.